Okay, so looking at this function again, um, in algebra, we'll look at how we can multiply to analytically show how to do these types of limits then. So what you want to do is multiply both the numerator and denominator by 1 over x squared, since x squared here is the biggest power we see in the denominator. Once we do that, if you multiply through by everything, it'll change what our biggest power is here then. So basically this x squared gets distributed, so it would cancel with that one. And then one of these would cancel with the second one, leaving an x here in the denominator. If we do the same thing with the denominator, we'd end up with this. It'd be basically, again, distributing this to each thing, we'd end up with what's there. So now as we go to infinity, we know some things are going to happen. Anything with a power of x equal to or bigger than 1 in the denominator, all those are going to go to 0 as we go to infinity. And so what we're left with is 4 over 1, which would just give us the result then of 4. And so the answer to that limit would be 4 by using that approach. Okay, so we're going to take that same approach here, doing some of these limits as we go to infinity. Remember, this is only as you go to infinity or negative infinity. So on the first one, look at what's the biggest exponent you see in the denominator, 3. So what that tells us here is we're going to multiply both the numerator and the denominator by 1 over x cubed. So now let's rewrite our limit here. Our limit as we go to infinity. In the top, as we distribute that, that's going to end up being just 4 minus 5 over x cubed. In the denominator, if we distribute that, x cubed over x cubed would be 1. On the next one, we would get plus 2 over x. So as we go to infinity, both these two here are going to go to 0. And so what we're going to be left with then is what we're going to be left with is, there we go, 4 over 1, which would equal 4. So that would be the solution to this one. All right, let's try another one. In the second one, looks like biggest power there is 1 over x to the 4th. So we do same. So we're going to do that on this one. So now our limit here becomes, on top, if we distribute that through, we get 4. The next one of those x's would cancel, so it'd be 6 over x cubed, and then plus 1 over x to the 4th. On the bottom, we do the same thing. We're going to get 1 over x to the 4th minus, there the x to the 4th would cancel, so it'd just be minus 2. And so again, all of these ones where you have an x with a power 1 or bigger, those are all going to go to 0 as we go to infinity. So what this is going to end up equaling then is 4 over negative 2, which would just end up equaling negative 2. So this one has a horizontal asymptote at negative 2. Okay, next one. Biggest power we see is x to the 10th. So here we're going to multiply by 1 over x to the 10th. Same thing on the bottom. Now let's again rewrite our limit here as we go to infinity. On the top, we're going to end up with 4 over x squared. Next one, 6 over x to the 7th. Next one, we're going to have plus 5 over x to the 9th. On the bottom, x to the 10th over x to the 10th is 1, plus 1 over x to the 10th. Now this one's a little different from the previous two. Here, everything on the top would go to 0. So what this one's going to do then is approach 0, and then on bottom we'd have this term going to 0, so it'd be over 1. Well, 0 over 1 is 0. This one's going to go to 0, or it means it has a horizontal asymptote at 0. All right, last one. On this one, biggest power we see is x to the 3rd. So here we're going to multiply by 1 over x cubed. So again, let's rewrite our limit And this one as we go to negative infinity. So on top, x to the fourth over x cubed, that would just be x. Minus, this one would simplify to 3 over x squared. If we distributed it to the 1, it'd be 1 over x cubed. Next one, 3x cubed over x cubed would simplify to 3. And the next one, we'd get 6 over x squared. So all these are going to, again, all these ones where you have the x in the denominator bigger than 1, they're all going to 0. So now our limit would become, limit as we go to negative infinity of x over 3. So what's that going to go to as we go to negative infinity? Well, if we keep putting bigger and bigger negative numbers in place of this x right here, that's going to be a big negative number divided by positive 3. Should give us a big, still a very big negative number. And so this is going to approach negative infinity. It's just going to keep getting larger and larger negative numbers. So that one would approach negative infinity. Had this been positive infinity over here, then our answer, final answer would be positive infinity. But because it's going negative, it would be negative infinity.